This next little group of standards that we're going to do is called trig proofs, also called trig identities. These are a little bit different than geometry proofs, but they're also a little bit the same. You'll sort of see the similarities here. But what we're going to start with is a lot of stuff that actually is review, which is good because we've had 3 weeks off. But we're going to be, on this page here, basically looking at some building blocks that we're going to use to do some proofs. So first, a little review here. We're talking about some reciprocal identities. So we know that sine and cosecant are reciprocals of each other. So what that means is that sine is 1 over cosecant, and vice versa, cosecant is 1 over sine. Let's think about this in terms of angles on the coordinate plane. So sine is y over h, right? Y over the hypotenuse. What is cosecant? H over y. Yeah, so they're reciprocals. Now remember, on the unit circle, there's a small difference here. What does h equal? Yeah, h equals 1. So on the unit circle, we would say sine is y, and cosecant is just 1 over y. But remember that there's more angles out there than just the unit circle. So we'll use y over h for this. So cosine and secant have the same relationship. They are reciprocals of each other. So cosine is the same as 1 divided by secant. Secant is the same as 1 divided by cosine. What is cosine in terms of x, y's, and h's and all that good stuff? What is it? A over h? Okay, yeah, a over h is right. Let's put it in terms of x and y. X over h, yeah. Yes, a over h is correct. And then secant would be h over x. And I'll just remind us of what we're talking about here when we talk about x and y. X, y, h. Sometimes instead of h, we use r for the radius. I prefer to use h. What is tangents? Y over x. Nice. What is cotangent? X over y. There we go. And those are reciprocals of each other. So the word reciprocal means either flipping the fraction upside down, or it means 1 divided by those numbers. Those are the same thing. Sometimes that gets a little bit confused. But flipping a fraction and doing 1 divided by a fraction are the same thing. Okay, we've got some new-ish identities. You might know these, you might not. We call these quotient identities. So tangent is the same thing as sine divided by cosine. So remember that sine is y over h. So that would be then divided by cosine. What does cosine equal again? X over h. And then what could happen here in this fraction for the fraction? The h's cross out, the h's cancel. So we're left with just y over x, which is tangent. Hey, how about that? If we think of this just on the unit circle, when we're not really paying attention to h at all, sine is y, cosine is x, so tangent is sine over cosine, which is y over x. And the same thing happens with cotangent. It's the reciprocal, of course, so if tangent is sine over cosine, cotangent would flip those two. Or we could see that played out here. Cosine is x over h divided by y over h. H's cancel, and we get x over y. Okay. So those are, again, just some building blocks is what we're doing here. We'll see how these come into play on the next page. All right, so we got another new guy. down here called, well, there's multiple Pythagorean identities, but this is kind of the main one. And so we're going to prove it real quick. So basically what this is saying, not basically, literally what this is saying is sine squared of theta plus cosine squared of theta equals 1. We'll talk about what the heck that means as we prove it. So we're going to use this picture again. Okay, so Pythagorean, that word right there, Pythagorean theorem. What would the Pythagorean theorem say is true about this picture? Sorry, what's that? I heard it. Say it with feeling. Equals h squared. Okay, yes. X squared plus y squared equals h squared. Pythagorean theorem is a squared plus b squared equals c squared. Applied to this triangle, yes. X squared plus y squared equals h squared. Do you guys believe the Pythagorean theorem? Do you believe that it's true? Okay. Hopefully, yeah, if you're questioning whether or not this is true, that might mean that a lot of math in general is kind of just up for debate for you, which sounds like a hard world to live in. But yeah, I'm not going to prove that the Pythagorean theorem is true. I kind of could. There's like a lot of different proofs for it. I sort of remember 3/4 of one of them. But there's a lot of proofs out there. So I'm not going to prove this. We're going to take this like we know that it's true. It's been proven a lot. We can trust it, hopefully. Okay. So what I want to do is I want to take this Pythagorean theorem, and I want to take this h squared, and I want to turn it into 1 somehow. But I have to use math rules. I'm not allowed to just, do whatever I want. I'm not allowed to just cross that out and change it to a 1. The reason I want to change it to a 1 is because this one has a 1 here. I'm also seeing a something squared plus something squared equals 1. So what's like a math operation that I could do to both sides that would change h squared into 1? Divide by h squared, yes. So I have x squared plus y squared equals h squared. I'm going to divide that by h squared. And if I divide on one side by h squared, I have to divide on the other, which means divide everything by h squared. So now what we have is x squared over h squared plus y squared over h squared equals 1. Okay, tracking? See what's going on here? All right. Am I allowed to do this and undistribute that exponent? Yes. Standard 6, properties of exponents. Okay. X over h, what does that equal? Cosine. And y over h? Sine. Okay, turn to your neighbor and say, what the heck just happened? Okay, answer your neighbor's question. What the heck did just happen? Okay, do we follow? We good? Everybody good? Any questions on how we got here? Questions on how we got here? Feeling good? Tracking? Okay. I am gonna just reorder them because that's the order that they started off with. Is everyone cool with that? Commutative property of addition. It doesn't really matter, but I just like it to look like they would go. Okay, now you might notice that this is really, really close to what we were trying to prove. It's just written differently. And so actually, sine squared means sine of theta times sine of theta, right? Anything squared means something times itself. The way that we write this, like the correct way to write it in math, is to write sine squared of theta. So this thing right here is actually the same as sine squared theta. The reason that we write it that way is it's because it would be annoying to write the parentheses every time around the sine. And if I write sine like theta squared, then that looks like it's theta being squared and not sine of theta being squared. So we put the squared between the n and whatever the variable is to show that it's sine times sine. So it's just a weird way of writing it. So actually we did prove it. We're at the answer here. Cha-ching. Okay, I'm gonna kind of wall this off here. Okay, so now we've proven that this is true. That sine squared plus cosine squared equals 1. We know it's true. There's the proof. We only used true things that we were allowed to do, Pythagorean theorem, and properties of math. And so we've shown that this is true. So what if I said, okay, well, what does sine squared of theta equal if this is true? One plus cosine squared theta?
Or 1 minus cosine squared.
1 minus cosine squared theta. Yeah, so if I took that equation and I subtracted cosine squared from both sides, minus cosine squared, then I would have it solved for sine squared theta. Yep. Same logic, what does cosine squared equal? Yes. So cosine squared equals 1 minus sine squared. So right now we have 1, 2, 3 different versions, or dare I say variants, of this original equation. We're actually going to end up with a total of 9 of these. We're only going to talk about 3 of them today. We'll talk about the other 6 next class. So leave some space. We're going to get all the way to 9 next class. No spoilers, though. No spoilers. Okay, so let's go to the back. We'll take a look at number 1. So using everything that's on the other side of the page, again, those are like our building blocks, like our box of Legos that we have, and now we're going to build like a ninja castle or a Death Star or something cool. We're going to try and prove that cosine is the same thing as saying cotangent times sine. Trying to show that that's true. here is something I am super not allowed to do. I am not allowed to divide both sides by sine of theta and have it cancel out. I'm not allowed to do that. Can anyone think of why not? Check your partner, talk about it for a sec. Why am I not allowed to do that? Okay. Any thoughts? Why am I not allowed to do this? Vivian.
I don't really know why not. I kind of know why it'd be counterproductive.
Okay.
Well, cotangent is equal to cosine of theta over sine of theta. And if you keep it there and then you multiply those two together, you'll get out cosine equals cosine.
Well, if I divide both sides by sine, don't I have cosine over sine equals cotangent? That seems like it would be productive.
You're right.
Okay. Good thought, though. Laura, what do you think?
I think that you could only do that when we know the sides are equal.
Okay. You can only do that when we know the two sides are equal, as it says at the top of the paper. But that's what we're trying to prove. We're trying to prove that the two sides are equal. So think about this like in a courtroom setting. If you're the prosecutor, you're trying to prove that someone's guilty, and you say, well, if they were guilty, then they would have been here at this time, then they would have done this thing, then we would have caught them, and then they would be here. Like, does that prove someone guilty? If you're assuming that they're guilty to start with and say, well, if they were guilty, then this all would make sense. I don't know if you guys know law procedures. That is super not allowed. That's bad lawyering. The defendant would get acquitted, no doubt. You can't assume something's true to then prove that it's true. You have to use logic and rules and things that you know to arrive that that is the only conclusion. So when we divide both sides by the same thing, we're assuming that both sides are equal. But I'm actually trying to prove that both sides are equal. I'm trying to show it. Does that make sense, more or less? Or do we agree to accept those rules at the very least? Don't do the same thing to both sides. If you ever do the same thing to both sides in one of these proofs, you will immediately fail it. You can do it 100% right until the very last line. If you do the same thing to both sides, complete F. It's all gone. It's all wasted.
Actually,
Okay. Well, now there's an NP, so. Yeah. Yeah. Okay, so question
that's not a good attempt.
about this proof that we did on the other side. Did I not break what I just said was the one rule? Wait.
Oh, no.
Oh.
Do I have to like erase that all?
Yeah, so is this all wrong? Is this all invalid? Have I led us astray? Did I trick you guys?
Well, I don't. Well,
We're
at least
supposed to know that. We
was
didn't
like
learn it.
when you had like x squared plus y squared equals x squared.
Okay, yeah, the only time I did it was right here with x squared plus y squared equals x squared. I only did it once. So what were you going to say?
I would say it's not like correct because you said that we will assume that that is equal to each other, so it's fine. Oh.
Yes. Okay. We know that the Pythagorean theorem is true. And we can assume it's true because it's been proven before. We can take this as a fact. I don't need to prove that that's true. Therefore, I know that both sides are equal. I am allowed to do the same thing with both sides because this is a proven theorem. Okay. What was not proven was this. I couldn't take this thing and start doing things on both sides until I prove that it's true. But I can do it with the OG Pythagorean theorem because back in the day, Pythagoras and his homies proved that it was true. Okay, yes. So that is the key difference. I only did it with something that we knew was true. Do we know for a fact that cosine equals cotangent times sine? No, we don't. Not yet, at least. We're about to, but we don't know it yet. So that's the difference. Okay. So here's what we have to do. We have to use the things on the other side to work on the side, but not across the sides. So is there anything that could be replaced with something else in number 1 here? Baby, what do you got?
You can replace cotangent with cosine of theta over sine of theta.
Okay, so we can replace that with cosine theta over sine of theta. That's one of our quotient identities. Now, in geometry, we would have to do it like this: statements, reasons, and we would say quotient identity. Okay, we don't have to do that. Don't do that. Fear not. Okay, now that we've replaced cotangent with cosine over sine, is there anything else that we could do? Okay, we can cross off sine. We are multiplying by sine and then dividing by it. Those things cancel out. And we are left with cosine equals cosine. Cha-ching. That's cool. Yeah. Okay, so with these proofs here, our goal is to get the two sides to match. So here we've ended up at cosine equals cosine. Sometimes you'll end up with 1 equals 1. Sometimes you'll end up with cosine 2x minus 3 equals cosine 2x minus 3. Probably not. But as long as the two sides say the exact same thing, then you have finished the proof. A challenge for you guys is to only work on one side and to get it to match the other. You know, you do not have to do this. In honors pre-calc, they have to do it this way. In regular pre-calc, which we're in right now, we do not have to do it that way. Technically, this is like the official way to prove something, so that's why. Now, I will say, in the next few weeks, we're going to be talking about classes that you can take next year for some of you guys. Obviously, the ones that are seniors, we're not going to talk about that. But if you're thinking of taking AP Calculus next year, AP Calculus, I'm going to encourage you to attempt the challenge as often as possible. But yeah, we'll talk about that more in the coming weeks. Don't worry. Okay. We have some strategies here for proofs that can help us out. Changing things to sines and cosines. Finding a common denominator. Factoring. Pythagorean identities. The main one, really, though, is just to try something. If you see one thing in a proof that you can do, go ahead and do that. Because a lot of times what happens is you then see something that you can do next. Think of this first one here. Did you guys know at the beginning of the proof that sine was going to cancel out? No. But once we change cotangent to cosine over sine, then we can see it. Right? So a lot of times there's a clear next step, and maybe you don't know where it's going, but this is kind of like a puzzle. Just go ahead and try it. Sometimes you find yourself in a dead end, and you just got to erase a little bit and try again. But if you're just sitting and staring at it, I promise that does not work. I tried that on this unit in high school. It did not work. I'm good at it. Okay, ideas on how to start number 2. Like,
Simplify cotangent.
okay. What do you mean simplify it?
Like, instead of saying cotangent, it's say cosine over sine.
Okay, yeah, so we can change cotangent to cosine over sine. Let me show you there's 2 ways that you can do this. You could do it like this. Or you can do it like this. Okay, this is cotangent right there. Cosine over sine. The top of the fraction goes to the top of the fraction. The sign on the bottom, that one can really go down there. These are both legal. They're both equivalents. I would say the one on the left is easier to understand. It's just a direct replacement. But the one on the right is easier to work with, I would say. Because look, it just cancels out and you get one. I like to avoid fractions within fractions if I can. The one on the left, we can see that sine's going to cancel. Then we're left with cosine over cosine. That is going to cancel. We are going to be left with 1 equals 1. But this one here too, cosines cancel, sines cancel. We're left with 1 equals 1. So either way it works. Up to you. Kind of depends on which one you see. Notice in both of these first two, we have done it the honors way. We only worked on one side of the proof. Questions on either one of these? Okay. With your partner, go ahead and do number 3. Ready, set, go. Okay, so one thing I will say, don't, as much as Y's and H's and X's can be helpful, don't use them actually in the proofs. You can use them to help you figure it out, but the actual proof shouldn't have them in there. But yeah. So as we're doing this, what's something that I could do on the left side?
You can change sine to y over 1.
Well, okay, so I don't want to change it into Y's and X's. I want to leave those out of it. What could I do on the left side? What could I rewrite? What's that? 1 over cosecant? What's 1 over cosecant? Sine. Okay, sine is the same thing as 1 over cosecant. So I have 1 over cosecant times cosecant. Or a way that I could write that is cosecant over cosecant. Doesn't matter. You might not have done it this way. It's okay. What about on the other side? Mikey?
Cosine times 1 over.
Yes, cosine times 1 over cosine, which can be rewritten as cosine over cosine. If you wanted to skip that step and just go straight to something like this, that's fine. A lot of people out there probably did sine over sine instead of cosecant over cosecant. Totally, either way, it's fine. Yeah, you're going to find that there's more than one way to do these proofs. Both sides cancel, and we get 1 equals 1. Okay. Questions on that one? Solid. How do you do it the challenge way? Wow. Great segue. Okay, here's how you do it the challenge way. So what I would do is, I would start on the left side. I used sine instead of cosecant, so I would change that to sine over 1 over sine. And my other side is going to stay the same over here. You know, this cancels out over there, so I'm left with 1 equals cosine times secant. Then what I would do is I would change that 1 into a cosine over cosine. So I'm like building it back up so that it equals the other side. And then this is 1 over cosine. And 1 over cosine is secant. So then I would be left with cosine secant equals cosine secant. So really, in order to do that, I probably would have done it this way first. Most of the students in the honors class will do it our way, working on both sides first, and then basically figure out, okay, that's how it's going to simplify. Let me see if I can go backwards, like simplify it down and then build it back up. Crazy. But yeah, again, you don't have to do it that way, but if you think about taking an AP math class next year, go ahead and try it. Questions on that? Either version. All right, try number 4. Ready, set, go. So this guy right here, 1 minus sine squared. Where is that? What does that equal? That equals cosine squared. Okay, that is one of our variations right there. 1 minus sine squared equals cosine squared. Yep. Yes, so that means I can just replace it. I'm going to clear some space here. That gets replaced, so now I have cosine equals cosine squared over cosine. What's cosine squared divided by cosine? Just cosine. So rules of exponents, right? It's like I have x squared divided by x. We subtract the exponents, the powers reduce. That would just equal x. This one we just get cosine equals cosine. Cha-ching. Questions on that one? Mike?
So, did you just get sine? So negative sine squared is equivalent to cosine?
No, 1 minus sine squared is equivalent to cosine squared.
Oh, okay.
Other questions? Okay, so remember some of the strategies up here. Change the sines and cosines, find common denominators, factor. This one here is the one we just used. Look for Pythagorean identities. Anytime you see sine or cosine squared or something squared, there's a decent chance you're going to use that. It's pretty good. It's probably like 80%. More than decent. Okay, do number 5. Ready, set, go. There's more than one way to do this one. There's a lot of ways. Someone, where can we get started? What's something we could do? Like,
Simplify tangent.
what do you mean simplify?
Like, change the tangent to sine over.
Okay. So yes, that's one way to do this. Not everyone did it this way. That's okay. So we're changing this to tangent is changing to sine over cosine. Cosecant is changing to 1 over sine. All right. If we have this, what can we do next? Again, sometimes it can be hard to figure out what to do next if you did the proof a different way. Okay.
This might be like completely wrong, but did you say the 1 over sine versus sine cosine over sine?
Yes, absolutely. That is completely right. So remember, and I mentioned this earlier, reciprocal means either 1 divided by a fraction or a fraction turned upside down. So if I do 1 divided by a fraction like that, that is the same as the fraction turned upside down. Remember, 1 divided by a fraction here means multiplied by the reciprocal. So yes, 1 divided by sine over cosine is the same as cosine over sine. And then that's what we have on the other side. I'll just put the sine underneath the cosine. And that works. Did anyone do this a different way? Or a slightly different way? Dave, what do you got?
Switch the 1 over and just
Mm-hmm.
And I put cosine, cosecant of sine.
Okay. Yes. And so then we get this cotangent equals cosine over sine, which is true. Yeah, so that I saw quite a few people start it this way. Change the 1 over tangent into cotangent. I wrote it this way just to make a quick note here. Could I stop here with cotangent equals cosine over sine? No, I can't stop here. Even though this is a true statement, I need to make the sides match exactly. And I could, it doesn't matter what they match, I could do cotangent equals cotangent. Or I could do the same ending spot as I had before, as long as the two sides have the same thing written down. Okay. Anyone do this a different way? Okay. You know, similarly, if I have 1 over tangent here, change that into cosine over sine. Change that into cotangent. Change cotangent into 1 over tangent. This would be the honors way. Again, like this one here is sort of all the same process. Okay. We're gonna do number 6 together because it is a doozy. All right. We got a lot going on here in this proof. Would we agree? Yeah, for sure. For sure. Let's take a look at our strategies. What's the first strategy on there? Change to sines and cosines. Okay, let's start there. Let's change to sines and cosines. Real quick, can I do this? Cancel out the cosecants.
No.
No, heck no. Under no circumstances can I do that. Absolutely not. Okay. When things are added together or subtracted, you cannot split them up by canceling things out. Like, you just can't do it. We've got subtraction here. That means like this whole thing is like a unified object. You can't split up part of it. It's like saying, you know, if I have 6 plus 1 over 6 minus 2, if I cross out the 6's and make it negative 1/2, that ain't right. 6 plus 1 over 6 minus 2 does not equal negative 1/2. It equals 7 over, what, 5? Okay, that's different than negative 1/2. Those are different things. I cannot cancel this out. It doesn't work. Okay, so changing to sines and cosines. What does cosecant equal again? 1 over sine. And cotangent equals? Cosine over sine. Okay. Oops. Okay. So we're here. Now we've got fractions over fractions. Is there anything that I can do with this? What's up? Cancel the signs. Am I allowed to cancel out all the signs? Yes, we are. We are allowed to do this. Here's why. Because if I combine those into one fraction, that's 1 minus cosine divided by sine over 1 plus cosine divided by sine. Would you guys agree here that we could cancel out the signs? Yeah, we did this earlier today. 2 fractions dividing each other with the same denominator, they cancel here. So if I could cancel them there, I can cancel them the step before. So if you have fractions within fractions, adding or subtracting, if they all have the same denominator, you can cancel them out. Because if you would combine into this here, they definitely cancel out. And so, why not just do it one step before? this is an advanced math move that we're going to use a lot this year. It's a pro strat. Okay. Now, as I'm working over here, all of a sudden this thing went from looking kind of weird to looking really complicated to all of a sudden now being pretty simplified. I mean, can I cancel the ones? Absolutely not. Okay, that's pretty simplified. So maybe I'm thinking, all right, let's go to the other side. Let's see what we got. What's the next strategy on there? Common denominator. Oh, okay, we did that. Yeah, yeah. I don't see any common denominators on the left side. All right, what's the next strategy? Factor. Ooh, can we factor?
Yes.
Yes. Maybe.
No. Probably.
Yes. Yes. Brandon's shaking his head, even though I know for a fact we just factored this one. This guy right here, 1 plus 2 cosine plus cosine squared, has the same structure, you may notice, as 1 plus 2x plus x squared, which is just x squared plus 2x plus 1 written backwards, which factors into x plus 1 times x plus 1, which means this thing factors into, I would probably rewrite this as 1 plus x, which means this guy factors into 1 plus cosine, 1 plus cosine. Okay. You guys might remember that there was a day when we were factoring with natural log and logarithms. You guys remember that? Factoring logs and logarithms? Maybe? On that day, I told you that we would soon factor with sine and cosine. And here we are. The day has come. The day is upon us. Okay. So we can factor that. It factors like that. Now, as I'm looking at this, I've been able to do something with 3 out of the 4 parts of this big fraction that we started. When I first looked at this problem, I would say that sine squared was probably the most simplified thing here at the beginning of the problem. But what do we think? Do we want to do anything with that, or do we want to leave it? Should do something with it? Why?
It's a little simplified thing. You can kind of mix it up.
True, yes. It's the thing that looks the nicest one in that room. Yes, agreed. Other thoughts? Should we do something with it? Any compelling reasons why? Tim?
Just to see if everything works nice once you do it.
Okay, see if everything looks nice once you do it. Sava? Oh, okay. Everything is cosine except for this one sine squared, right? So if we change that into 1 minus cosine squared, now everything is cosine. It's kind of like high school, right? If you're different, you want to fit in. Just kidding. That's a bad message. Don't listen to that. Be yourself. Okay. What do I do now? Vivian.
Divide the top and the bottom by 1 plus cosine.
Okay, how can I divide by 1 plus cosine?
No idea, I just know that I can do it.
Okay. You're right, but why though?
Well, I know why I do it.
So here's what I'm looking at here. Let me just write it down here real quick. These two sides are almost the same, right? It's all cosine. On the left side, we have 1 minus cosine squared. On the right side, we have 1 minus cosine. On the left side, we have 2 1 plus cosines. On the right side, we just have 1 1 plus cosine. So we're pretty daggone close. Ideas of what we do. Expand the cosine squared. How?
1 minus cos.
1 minus cosine, 1 plus cosine. Oh, are you using difference of squares?
Yes. Yeah.
Ah.
That's also, yeah. That's not far away. Yeah.
So 1 minus cosine squared equals 1 plus cosine times 1 minus cosine. Oh, wow. Okay. Well, that's marvelous. And now what?
I'm a little bit confused.
Okay, so what just happened was we recognized that 1 plus cosine squared is difference of squares from algebra 2. You have something squared minus something else squared. So a squared minus b squared factors into a plus b, a minus b, which means that 1 minus cosine squared factors into 1 plus cosine, 1 minus cosine. Okay, other questions on how we got here? Questions like, wait, how did you do that? Are great questions to ask at this juncture. Scanning. Okay, remember that I cannot read your facial expressions, so I don't really know if you're confused or not. So now's a great time to ask. Okay, how would I finish this proof? What would I do? Yes, okay. So, we cannot cross off like these ones right there. We're not allowed to do that. We can cross off this whole 1 plus cosine and this whole 1 plus cosine because those things are being multiplied to the other expression. I'm not splitting up addition. I'm keeping it all together. I'm just crossing off the addition with the addition below it because those two things are being multiplied. One thing too, make sure that you write theta in all of these things, or like in the next problem here, like make sure you keep x in there. If you just write cosine by itself with no variable, it's not right. But here we are, we've made it. Okay. That's the end of our notes for today. That's the end of our notes for today. There's always more days and always more notes. Questions on any of this? I'm about to give you guys the homework.